Military technology is the application of technology for use in warfare. It comprises the kinds of technology that are distinctly military in nature and not civilian in application, usually because they lack useful or legal civilian applications, or are dangerous to use without appropriate military training. The line is porous. Military inventions have been brought into civilian use throughout history, with sometimes minor modification if any, and civilian innovations have similarly been put to military use. Military technology is usually researched and developed by scientists and engineers specifically for use in battle by the armed forces. Many new technologies came as a result of the military funding of science. On the other hand, the theories, strategies, concepts, and doctrines of warfare are studied under the academic discipline of military science. Armament engineering is the design, development, testing, and life cycle management of military weapons and systems. It draws on the knowledge of several traditional engineering disciplines, including mechanical engineering, electrical engineering, mechatronics, electro-optics, aerospace engineering, materials engineering, and chemical engineering. The first use of stone tools may have begun during the Paleolithic period. The earliest stone tools are from the site of Lamikwai, Turkana, dating from 3.3 million years ago. Stone tools diversified through the Pleistocene period, which ended 12,000 years ago. The earliest evidence of warfare between two groups is recorded at the site of Nataruk in Turkana, Kenya, where human skeletons with major traumatic injuries to the head, neck, ribs, knees, and hands, including an embedded obsidian bladelet on a skull, are evidence of intergroup conflict between groups of nomadic hunter-gatherers 10,000 years ago. Humans entered the Bronze Age as they learned to smelt copper into an alloy with tin to make weapons. In Asia, where copper tin ores are rare, this development was delayed until trading in bronze began in the 3rd millennium BCE. In the Middle East and southern European regions, the Bronze Age follows the Neolithic period, but in other parts of the world, the Copper Age is a transition from Neolithic to the Bronze Age. Although the Iron Age generally follows the Bronze Age, in some areas the Iron Age intrudes directly on the Neolithic from outside the region, with the exception of sub-Saharan Africa where it was developed independently. The first large-scale use of iron weapons began in Asia Minor around the 14th century BCE and in Central Europe around the 11th century BCE, followed by the Middle East, about 1000 BCE, and India and China. The Islamic gunpowder empires introduced numerous developed firearms, cannon, and small arms. During the period of proto-industrialization, newly invented weapons were seen to be used in Mughal India. Rapid development in military technology had a dramatic impact on armies and navies in the industrialized world in 1740 to 1914. For land warfare, cavalry faded in importance, while infantry became transformed by the use of highly accurate, more rapidly loading rifles, and the use of smokeless powder. Machine guns were developed in the 1860s in Europe. Rocket artillery and the Mysorean rockets were pioneered by Indian Muslim ruler Tipu Sultan, and the French introduced much more accurate rapid-fire field artillery. Logistics and communication support for land warfare dramatically improved with use of railways and telegraphs. Industrialization provided a base of factories that could be converted to produce munitions, as well as uniforms, tents, wagons, and essential supplies. Medical facilities were enlarged and reorganized based on improved hospitals and the creation of modern nursing, typified by Florence Nightingale in Britain during the Crimean War of 1854–56. Naval warfare was transformed by many innovations, most notably the coal-based steam engine, highly accurate long-range naval guns, heavy steel armor for battleships, mines, and the introduction of the torpedo, followed by the torpedo boat and the destroyer. Coal after 1900 was eventually displaced by more efficient oil, but meanwhile navies with an international scope had to depend on a network of coaling stations to refuel. The British Empire provided them in abundance, as did the French Empire to a lesser extent. War colleges developed, as military theory became a specialty. Cadets and senior commanders were taught the theories of Jomini, Clausewitz, and Mahan, and engaged in tabletop war games. Around 1900, entirely new innovations such as submarines and airplanes appeared, and were quickly adapted to warfare by 1914. The British HMS Dreadnought, 1906, incorporated so much of the latest technology in weapons, propulsion, and armor that it at a stroke made all other battleships obsolescent. Organization and finance. New financial tools were developed to fund the rapidly increasing costs of warfare, such as popular bond sales and income taxes, and the funding of permanent research centers. Many 19th-century innovations were largely invented and promoted by lone individuals with small teams of assistants, such as David Bushnell and the submarine, John Ericsson and the battleship, Hiram Maxim and the machine gun, and Alfred Nobel and high explosives. By 1900 the military began to realize that they needed to rely much more heavily on large-scale research centers, which needed government funding. They brought in leaders of organized innovation such as Thomas Edison in the US and chemist Fritz Haber of the Kaiser Wilhelm Institute in Germany. Postmodern technology. The postmodern stage of military technology emerged in the 1940s, and won with recognition thanks to the high priority given during the war to scientific and engineering research and development regarding nuclear weapons, radar, jet engines, proximity fuses, advanced submarines, aircraft carriers, and other weapons. The high priority continues into the 21st century. It involves the military application of advanced scientific research regarding nuclear weapons, jet engines, ballistic and guided missiles, radar, biological warfare, and the use of electronics, computers and software. During the Cold War, the world's two great superpowers, the Soviet Union and the United States of America, spent large proportions of their GDP on developing military technologies. The drive to place objects in orbit stimulated space research and started the space race. In 1957, the USSR launched the first artificial satellite, Sputnik 1. By the end of the 1960s, both countries regularly deployed satellites. Spy satellites were used by militaries to take accurate pictures of their rivals' military installations. As time passed, the resolution and accuracy of orbital reconnaissance alarmed both sides of the Iron Curtain. Both the United States and the Soviet Union began to develop anti-satellite weapons to blind or destroy each other's satellites. Laser weapons, kamikaze-style satellites, as well as orbital nuclear explosion were researched with varying levels of success. Spy satellites were, and continue to be, used to monitor the dismantling of military assets in accordance with arms control treaties signed between the two superpowers. To use spy satellites in such a manner is often referred to in treaties as national technical means of verification. The superpowers developed ballistic missiles to enable them to use nuclear weaponry across great distances. As rocket science developed, the range of missiles increased and intercontinental ballistic missiles, ICBM, were created, which could strike virtually any target on Earth in a time frame measured in minutes rather than hours or days. To cover large distances, ballistic missiles are usually launched into suborbital spaceflight. As soon as intercontinental missiles were developed, military planners began programs and strategies to counter their effectiveness. A significant portion of military technology is about transportation, allowing troops and weaponry to be moved from their origins to the front. Land transport has historically been mainly by foot. Land vehicles have usually been used as well, from chariots to tanks. When conducting a battle over a body of water, ships are used. There are historically two main categories of ships, those for transporting troops, and those for attacking other ships. Soon after the invention of aeroplanes, military aviation became a significant component of warfare, though usually as a supplementary role. The two main types of military aircraft are bombers, which attack land or sea-based targets, and fighters, which attack other aircraft. Military vehicles are land combat or transportation vehicles, excluding rail-based, which are designed for or in significant use by military forces. Military aircraft includes any use of aircraft by a country's military, including such areas as transport, training, disaster relief, border patrol, search and rescue, surveillance, surveying, peacekeeping, and, very rarely, aerial warfare. Warships are watercraft for combat and transportation in and on seas and oceans. Fortifications are military constructions and buildings designed for defense in warfare. They range in size and age from the Great Wall of China to a Sangor. Further information on the patented portable armored wall system, McCurdy's armor. Sensors and communication systems are used to detect enemies, coordinate movements of armed forces and guide weaponry. Early systems included flag signaling, telegraph and heliographs. The Defense Advanced Research Projects Agency is an agency of the United States Department of Defense responsible for the development of new technologies for use by the military. DARPA leads the development of military technology in the United States and today, has dozens of ongoing projects, everything from humanoid robots to bullets that can change path before reaching their target. China has a similar agency. Current militaries continue to invest in new technologies for the future. Such technologies include cognitive radar, 5G cellular networks, microchips, semiconductors, and large-scale analytic engines. Additionally, many militaries seek to improve current laser technology. For example, Israeli Defense Forces utilize laser technology to disable small enemy machinery, but seek to move to more large-scale capabilities in the coming years. Militaries across the world continue to perform research on autonomous technologies which allow for increased troop mobility or replacement of live soldiers. Autonomous vehicles and robots are expected to play a role in future conflicts. This has the potential to decrease loss of life in future warfare. Observers of transhumanism note high rates of technological terms in military literature, but low rates for explicitly transhuman-related terms. Today's hybrid style of warfare also calls for investments in information technologies. Increased reliance on computer systems has incentivized nations to push for increased efforts at managing large-scale networks and having access to large-scale data. New strategies of cyber and hybrid warfare include network attacks, media analysis, and media/grassroots campaigns on media such as blog posts. Cyberspace. In 2011, the U.S. Defense Department declared cyberspace a new domain of warfare. Since then, DARPA has begun a research project known as Project X with the goal of creating new technologies that will enable the government to better understand and map the cyber territory, ultimately giving the Department of Defense the ability to plan and manage large-scale cyber missions across dynamic network environments. Thank you for watching this video.